Welcome to Accelerated Engineering. My name is John, and this is the video encyclopedia entry for the binom.dist.range function, for the binomial distribution over a range. What the binomial dist range function does is it calculates the probability that a test succeeds, or that a trial succeeds, between an upper and a lower bound of times. So for example, what I've got this calculating here is it is asking the question, if I perform 20 trials with and each one has a 50-50 chance of succeeding, 0.5, what are the odds, what is the probability that I will get between 10 and 12 successes inclusive? So let's just take a closer look at what that function inputs. So first of all, it asks for a number of trials. So in this case, we were using 20. Okay, hush. We were using 20. And then it asks for the probability. So in this case, it's easy to think of this like flipping a coin. Flipping a coin is 50-50, so we'll put in a 0.5 there. You could also do something like rolling a 20-sided dice and you use 0.05. But 50-50 is an easy one to visualize. The next value is the number S. It's the number of successes. It's the lower bound, which I just realized I think I've done backwards, and then the upper bound. So what we used between 10 and 12, and we'll get this value. And it says there's about a 46% chance. Now, did I definitely mislabeled these. Me. Okay. So to show that, what I've done on this graph is just highlighted the area. The blue line is the binomial distribution for this function, assuming 20 trials and between 10 and 12, 20 trials with a 0.5% probability of occurring. And then I've added the orange line just to show which portion of that probability is encompassed. We can change this. Like for example, if I wanted between 8 and 12, you'd see that that covers almost 3/4 of the time. So this is one way to use it. But either way, it'll give you that answer without having to draw out a graph or run all of the things and then sum up these individual probabilities. This is the quick way or the shortcut. Let's just do a couple of nice ones here. So let's go 20 and, oh, it won't actually go that high because I didn't plan for that range. Let's go if there's 10 things and a 0.05% chance of it occurring. It says that most likely what you want is not going to happen. The odds of this happening between 1 and 3 times is about 0.4. And it, again, just takes this chunk of the graph here. Okay, limitations for this function. The number of trials must be an integer number. Non-integer numbers get truncated. The probability must fall between 0 and 1 for reasons discussed in other videos. You can't have something that is less likely than 0 to happen, and you can't have something that is greater than 1 likelihood to happen. You can't be more definite than 100%. So from 0 to 1 inclusive. The lower number and the upper number must be things that are possible. First of all, I'm quite certain that the lower number has to, oh, actually that's out of range. Let's go back to the 20 and 0.5 just to make sure this is working. There we go. Yeah. So the lower number has to be smaller than the upper number. Otherwise, it throws a numerical error. You can't, yeah, well, that's just a requirement. And then the upper number has to be higher than the lower number. I guess I kind of already said that. And the lower number is optional, although I don't think I've graphed this. It's just asking about the odds of it being like greater than this. In this case, it's showing kind of the opposite thing. In a 0.5 probability 20 trials, what are the odds of getting at least 14 successes or greater than 14 successes? And it's about 4% for a coin toss, which is, not a lot. So related functions to this then are the binomial distribution function, binom.dist. There's the binom.dist.inv, or the binomial distribution inverted one, and I think I'll probably release that video shortly. And that's it. So this concludes the video encyclopedia entry for the binom.dist.range function. Please take a moment to click the like button, leave a comment if you want, and subscribe if you want to see more content like this. Thanks for watching. Happy excelling.